Hello, welcome to a video for grade 12 physics on conservation of energy. Energy in physics is a quantity that is always conserved, which means that it can be converted between different forms, but it can never be created or destroyed. Now, there are many different types of energy, such as potential energy, or kinetic energy, or electromagnetic energy. We always have to maintain the same amount of energy as we started when we're looking at a problem or we're looking at a system. Energy is conserved in our physics problems. For us in our mechanics unit, this means that when we look at kinetic energy, we're looking at a number that is conserved. If we know the amount of work done, we can figure out the kinetic energy change. A couple other things like that. Let's look at an example problem to sort of see what I mean here. In this case, we have a 10 kilogram object accelerated with a net force of 5 newtons over a distance of 6 meters. So if I start by saying my mass is 10 kilograms, my force here, my F net, is 5 newtons, and my distance traveled is 6 meters. If I look at this and I try and solve this using my grade 11 physics formulas, I use F equals ma. That's pretty common. So I'm going to do my net force of 5 newtons, and that works out to an acceleration of 0.5 meters per second squared. Now, if I want to solve this for my final velocity, I'm going to use Vf squared equals Vi squared plus 2AD. Great. Plugging this in, Vf squared equals 0 squared plus 2 times 0.5 times 6. And if I solve that through, I get a final velocity of 2.45 meters per second. So there we go. So in this case, I need to use this formula, F equals ma, and then I can use this formula, which I know, in order to figure out my final velocity. So this is the part for number 1 here, and this is a grade 11 solution where we look at this using Newton's laws and go, great, I can talk about this in terms of forces and masses and that sort of stuff. However, in grade 12, we're going to start talking about this using energy. So you may notice that the second question says without using F equals ma. There's a new formula in grade 12, which we learn, which is work is force times the displacement, the net force times the displacement. So if I'm going to use this formula and check on your formula sheet and your formula tree for this formula, we can start off by going my work is my force times my distance. So my work in this case is 5 newtons times 6 meters. So my work is 30 joules. Now, I know this is my work. The important thing here is energy is conserved. So the energy that is put in here, the work that is done, is converted to kinetic energy. My formula for kinetic energy is 1/2 times the mass times the velocity squared. This formula as well is on your formula sheet and is a really important one. So I can take my work here, which is converted to kinetic energy, and I can go my kinetic energy is 1/2 mv squared. So I can go 30 joules equals 1/2 times 10 kilograms v squared. And solving that through, I get 2.45 meters per second for my velocity. You can do the algebra on that one. The important thing about this equation here, or this question here, is realizing that my work and my kinetic energy are the same thing. In this case, my work and my kinetic energy are equivalent because my work is converted into kinetic energy. This here is true in this case because that's what the problem was set up as. But the idea is you find one form of energy and you can convert it to another form and use it there. In slightly more complicated problems, if you keep taking physics in university, you'll talk about many different types of energy and how to convert between them. Right now, we're just interested in this one, kinetic energy and work, and going back and forth between them. So this here is the key. My work and my kinetic energy are interchangeable in questions like this. I hope this has been helpful. Take a look at the next video and we'll do a slightly more complex problem like this. And we're going to be doing a bunch of questions with work and energy and all that sort of stuff, because this is a really important concept. Hope this helps, and I'll see you in the next video.